just thought I'd bring you a really interesting question from the BMAT from 2012. This is the Biomedical Application Test, I think it stands for. So as you guys are probably aware, I do lots of admission test help at school. And most of it is maths related, Matt, Tamura, of course. But someone someone who's doing the BMAT this year brought to me a BMAT question that they had found and couldn't do. And what's really interesting about this question, I'm hoping while I'm waffling here, I'm giving you time to pause and try this question here. What's really interesting is that this person who came to me for help here doesn't do A-level maths, right? They're in year 13, they dropped maths a year and a half ago. And so you have to do this question with someone who does not know any maths beyond GCSE and also hasn't really seen much maths for like a year, or proper maths at least. Yeah, I went there, sciences, you're not proper maths. So yeah, can you do this question only using GCSE maths in a way that just a strong GCSE mathematician who hasn't done it in a while would understand? So there's a challenge. That was the challenge that I had today at lunchtime when I was trying to do this. And I just thought it was really interesting. So yeah, go ahead. Okay, well, let's start from the bottom. So the only thing that a GCSE kid or someone who's only done GCSE maths would know about tan is equal to opposite over adjacent. That's the only thing that they would have seen. Like the first thing that came to my mind when I saw this was some tan compound rules. I also thought this might be a circle being defined at midpoint M, just because I'm mad about circle theorems, but basically all that this kid will understand is tan is opposite over adjacent. That's the only thing that tan exists in GCSE. And of course, this only works for right-angled triangles. So we need some right-angled triangles here. So let's put a line straight down from C and make a right angle down at B. Now, of course, M being the midpoint means this is equal to this, which will become useful later. So here's a line down making a right angle here. And so tan of CBA, which is this angle here, is 2 over 3. That means opposite over adjacent I can just define as 2 and 3, right? Going backwards by mistake. 2 and 3 there. But now we can look at the other side and we can say, well, tan of CAB is 1 over 6, which I can also say is 2 over 12, of course. So that's going to be 2 over 12, and I can say that entire distance there is 12. But this is really helpful because this is the midpoint, of course. And so now I've got the entire length is 15, 12 plus 3. The midpoint makes this distance here 7.5, and of course it makes this distance here 7.5, which means this little distance here, 7.5 minus 3, makes this 4.5. And now we realize that my drawing is terrible, but that's okay. And now we just need tan of CMB is, again, opposite over adjacent is going to be 2 over 4.5, which I can just double out to be 4 over 9, and that's the question. Just thought it was really interesting. There's probably lots of other really cool ways you can do it using some proper maths rather than this, but yeah, I just thought it was quite interesting.